Hello, my name is Mamer Zapaidari. In this video, I present my first assignment for my machine learning course at Simon Fraser University, where I built a basic machine learning workflow using the California housing dataset from data exploration to model training. At step 1, I downloaded the California housing dataset using the fetch housing data function, which creates a local folder, downloads the dataset, and extracts the Excel file. Then I loaded it into a pandas data frame. I use head to preview the data and understand its structure. The dataset includes various features such as location, housing age, and number of rooms, and other features. Using info, I checked data types and missing values. I found that total bedrooms has missing trees and that ocean proximity is a categorical variable. Next, I use value counts to examine the categories in ocean proximity. Finally, I plotted histograms to visualize distribution. Some variables such as total rooms, bedrooms, and population are right skewed, which is important for data preprocessing and model performance. In the second step, I created a test set. This is important because we need to evaluate the final model on data that the model has not seen during training. First, I use a function called split train test to randomly shuffle the dataset and split it into 80% for training and 20% for testing. However, random splitting can give a slightly different result each time and may not represent important patterns well. Since median income strongly affects house value, I created an income category feature by grouping income into categories. Then I applied a stratify shuffle split from scikit-learn, which ensures that both training and test sets have similar proportions of these income categories. This produces a more reliable and representative split. Finally, I removed the temporary income category column to restore the original dataset. In the third step, I explored the training data using visualization. I plotted longitude versus latitude to obtain a map-like view of California. By setting alpha to 0.1, dense regions became more visible, helping identify where most districts are concentrated. Next, I made a scatter plot in which circle size represents population and color represent median house value. This showed that coastal areas generally have higher housing prices, while inland regions are cheaper. Then I computed the correlation matrix. The key result that median income has the strongest positive correlation with median house value, which is about 0.7, indicate that higher income areas tend to have higher prices. I also use the scatter matrix to examine relationships between variables. The plot confirmed a clear upward trend between income and house value, aligned with a noticeable price cap around $500,000. Finally, I created new features such as rooms per household, bedrooms per room, population per household, which provide more meaningful information than the original variables. In the fourth step, I prepared the data for machine learning. I first separated the input features from the target variable. To handle missing values in total bedrooms, as I mentioned before, I use simple imputer with the median strategy. This approach is robust and can also handle missing values in future data. Next, I processed the categorical feature ocean proximity. I initially tried ordinal encoder, but it can impose an arbitrary order on the categories. Therefore, I use one-hot encoder, which creates separate binary columns for each category. I then created a custom transformer called combine attributes adder to generate those new features as I mentioned before. Finally, I built a numerical pipeline that includes imputation, feature addition, and standard scaling. Scaling is important because features have different ranges. I combine this with the categorical encoder using column transformer. The final output, which is housing prepared, is a clean and fully transferred dataset ready for machine learning. In the final step, I selected and trained a machine learning model. The goal is to predict median house value based on the prepared features. Based on that, I trained two models. One is linear regression and another is decision tree regressor. I evaluated performance using root mean square error. The decision tree showed near zero error on the training data, but this indicates overfitting. It memorized the data rather than learning patterns. based on the final model result, I understood that a perfect training result is not always good. Generalization is more important. Finally, to summarize, this project helped me understand the full machine learning workflow in Python. I learned how to load data, inspect missing values, visualize patterns, create a representative test set using stratified sampling, engineer new features, pre-process numerical and categorical columns, and prepare the dataset for model training. These steps are essential before applying more advanced machine learning algorithms. Thank you so much for your attention.